Hi everyone. Today we're going to study local extrema and critical points. Let us define some terms. Let's begin with local maximum. A function f has a local maximum at the point C if there exists an open interval I containing C, such that I is contained in the domain of f and f of C is greater than or equal to f of x for all x an element of I. Now let us define local minimum. A function f has a local minimum at the point C if there exists an open interval I containing C, such that I is contained in the domain of f, and f of C is less than or equal to f of x for all x an element of I. Now let us define local extremum. A function f has a local extremum at the point C if f has a local maximum at C or f has a local minimum at C. Note that the term local extrema is the plural form of local extremum. To illustrate, we have our graph here in blue color, and this is y equals f of x. Take note that some points of the graph are identified with some values of x, namely a, c, e, d, and b. On this graph, we say that there are two local maximum, and these are the points when x is equal to c and d. In here, we say that this is local maximum because there is no greater value of f nearby. And when x is equal to d, this point here is also called absolute maximum. We say that there is no greater value of f anywhere, or this is the highest point of the graph. Next, there are 3 points of local minimum, and these are the points when x is equal to a, to e, and to b. We consider this point as local minimum because we say that there is no smaller value of f nearby. The same is true with this point in here. But the point when x is equal to a, this point here is also called absolute minimum. We say that there is no smaller value of f anywhere. Or simply said, this is the lowest point of the graph in the interval. Now let us define critical points. Let C be an interior point in the domain of f. We say that C is a critical point of f if letter A, f prime of C is equal to 0, or letter B, f prime of C is undefined. Let us see example 1. Find the critical points of the function y equals 4x cubed minus 3x. For our solution, let us do the step 1, and that is to find the derivative. The derivative of this function now is y prime equals 12x squared minus 3. Step 2, we set y prime equals 0 and solve for x. So the y prime here becomes 0 equals the right side values. Let's solve for x now by first transposing this negative 3 to the left side. The negative becomes positive 3. And in here, we simplify this equation by dividing by 3. So the left hand becomes 1 is equal to 4x squared. Let us isolate the x squared by dividing this equation by its coefficient. Divide by 4. So we have now 1 over 4 is equal to x squared. This time, let us take the square root of both sides. So we have now x is equal to plus or minus the square root of 1 over 4. And we can simplify this into 1/2. So the value of x is equal to plus or minus 1/2. These are the critical points. Example 2. Find the critical points of the function f of x is equal to x squared over the quantity x minus 1, given that x is not equal to 1. For our solution, let us do step 1 to find the derivative. We can see here that our function is a quotient, so we will apply the quotient rule. So the derivative will be f prime of x is equal to x minus 1 times the quantity 2x minus x squared times the quantity 1 all over the square of the binomial x minus 1. Simplifying the numerator, we will have now 2x squared minus 2x minus x squared all over this same denominator. We can combine the 2x squared and the negative x squared. So our derivative now becomes x squared minus 2x all over this same denominator. This is now the derivative. Step 2, we set y prime or the derivative equals 0 and solve for x. So this f prime of x becomes 0, and let us rewrite our derivative here by factoring the numerator. So we have now x times the quantity x minus 2 over our same denominator. Let us now solve for x. Let us cross multiply the denominator to the left side. So this will be simplified into 0 equals the numerator itself, x times the quantity x minus 2. Now, let us equate each of the factors into 0. So we have this x equals 0 and the x minus 2 equals 0. We found the first value of x. This is the first critical point, x equals 0. And the second critical point, we transpose this negative 2 to the right side. We have now x is equal to 2. This is another critical point. So in here, we have 2 critical points. We take note that in our derivative here, we can see that the derivative is undefined when x is equal to 1. But since x equals 1 is out of the domain, you can see in here from the very beginning of the problem. So it is no longer considered as critical point. So on this problem, we have only 2 critical points, and those are x equals 0 and x equals 2. These are the final answers. I hope you learned something from this video. See you again next time.